Our goal for today's lesson is to learn how to solve trig equations. So there's a couple things to remember when we're solving trig equations. First, we can never try to solve by dividing by a trig function. So normally in the algebra, when we divide by a 3 or divide by a 6, those we can do without changing our domain. When we divide by a trig function, we might change the domains. We cannot divide by a trig function. You can multiply, you can add, you can subtract, but do not divide. And you always want to check to make sure your answer works. This goes back to, again, domain. You want to make sure that what you get does actually satisfy what you're looking for. So let's look at some examples. Our first example is to solve this equation on the interval of 0 to 2 pi. 0 is included, 2 pi is not included. So we have cosine cubed x equals sine x, over sine x equals cotangent x. So I can move my cotangent x to the other side. So I have cosine cubed x all over sine x minus cotangent of x equals 0. Now I can rewrite cotangent using my quotient identities. So I'll have cosine cubed x all over sine x minus cosine x over sine x. Here I see I have a common denominator, so I can combine this into a fraction. And I'll have cosine cubed x minus cosine x all over sine x equals 0. And then from here, I can factor out a cosine from the numerator. So I have cosine of x times cosine squared x minus 1 all over sine of x equals 0. Alright, so now I want to know where this equals 0. I have to remember that sine of x cannot equal 0 because of the denominator. So sine of x equals 0, x equals 0, and x equals pi. So we know we cannot include these in our final solution. We also know that when the numerator equals 0, the whole thing equals 0. So we can use our zero product property here to see when the numerator equals 0. So this means that cosine of x equals 0, or cosine squared of x minus 1 equals 0. So here we can use our inverse function. So we'll have cosine inverse of 0 equals x, and our x is going to be pi over 2 and 3 pi over 2, because that is where our x is 0 using our unit circle. So this, when you evaluate cosine of x at pi over 2 and 3 pi over 2, you'll get 0. Now let's go to the other side. We can add 1 to each side. We can take the square root of both sides. And we'll be left with cosine of x equals plus or minus 1. So we know that cosine of x is negative 1 at, well, cosine of x is 1 at 0, and we know cosine of x is negative 1 at pi. But remember, this doesn't satisfy our domain, so we cannot use it. Therefore, our answers are x equals pi over 2 and x equals 3 pi over 2. Alright, so let's try another example. So here we have 2 cosine x sine x minus cosine x equals 0. Again, we were looking just like before, that was written in blue. Our interval was 0 to 2 pi. And then from here, we have cosine x in both terms, so we can factor out a cosine x. And again, we can use our zero product property, and we'll get cosine of x equals 0, or 2 sine of x minus 1 equals 0. So here we can solve cosine inverse of 0 equals x, so x is pi over 2 and 3 pi over 2. Over here, add 1, and then divide by 2. So we want to find for 1/2, so we'll have sine inverse of 1/2 equals x. So you're going to know when, at what degree is the sine 1/2. So this is going to be pi over 6 and 3 pi over 6. And you can verify this using our unit circle. And there are no additional restrictions, so our answers are x equals pi over 2, 3 pi over 2, pi over 6, and 3 pi. Or 5 pi over 6, sorry. Alright. Now let's look at one more example here. This one will involve tangent. So we'll have the tangent of x, I don't know why it won't focus. Tangent of x equal times sine squared of x equals tangent of x. So looking at here, we don't see too much we can do, but let's start by pulling out a tangent of x. And I'm going to move this tangent to x to the other side. So what I did in between here is I had tangent of x, sine squared of x minus tangent of x equals 0. So that was that intermediate step there. And then I can use my zero product property again. I'll note tangent of x equals 0 or sine squared x minus 1 equals 0. And we know tangent of x equals 0 when sine is 0, so our x is 0 and pi. Here we can solve sine squared x equals 1, take the square root, sine of x equals plus or minus 1. So then here, plus or minus 1 is at pi over 2 and 3 pi over 2. But remember, tangent is undefined here, so we can't use this. Because that is not in our domain. We don't want to include undefined values in our domain. Alright, so now these are solving in the interval 0 to 2 pi. Okay, so now we want to look at what happens when we solve for all values. So here, I want to find all values of x that solve the following equations. So my first equation here is 2 sine squared x plus sine x equals 1. And so to start, I'm going to factor this. It's by moving the 1 over. So 2 sine squared x plus sine x minus 1 equals 0. And we can let y equals sine of x. So then I'll have 2y squared plus y minus 1 equals 0. And we can factor this into 2y minus 1 and then y plus 1. So we'll be left with 2, replacing our y back, 2 sine x minus 1 and then sine of x plus 1. And we can use our zero product property here to solve for all of our values. So we know that 2 sine of x minus 1 equals 0 or sine of x plus 1 equals 0. And we can solve for sine, so sine of x equals 1/2 or sine x equals -1. Okay, so looking at this from here, we want to find for what values, for what angles does sine equal 1/2, and that is going to be our pi over 6 and our 5 pi over 6. And we also want to find when sine of x is -1, and that's going to be at our value of pi, 3 pi over 2, sorry, 3 pi over 2. So now we want all values. So to find all values, we're going to have x equals pi over 6, and we have to go all the way back around, so it's going to be plus our 2 pi k. We have 5 pi over 6 plus our 2 pi k, and we also have our 3 pi over 2 plus 2 pi k, and for all of these, k is an element of the integers. Okay, so this is just like we did when we were solving for all values of our angles before. This is our final answer. So you always want to make sure you include that k is an element of z as well. So let's look at another example. we have sine squared x minus 2 sine x equals 0. So this one, our first step, we notice we have sine and sine, so you might want to pull out a sine x. Sine of x times sine of x minus 2 equals 0. Okay, so now we can use our zero product property again. We'll have sine of x equals 0 or sine of x minus 2 equals 0. We'll solve over here. Sine of x equals 2. We know sine can never equal 2, so we just leave that one as is. Here, sine of x, sine is 0 when x is pi or 0. So now we have x equals pi k. K is an element of C. Okay, so this can say to get the 0, we'll just have our k be 0, and to get pi, k will be 1, 2 pi, k will be 2, that sort of thing. Alright, we have one last example. 4 cosine squared x minus 4 cosine x plus 1. So we can let cosine of x equal y. Okay. And then from here, we can substitute it in. So 4y squared minus 4y plus 1 equals 0. And then we can factor this to 2y minus 1. 2y minus 1 equals 0. And it's the same as 2y minus 1 squared equals 0. And we can substitute our cosine back in. So we have 2 cosine x minus 1 squared equals 0. So we know that from here that 2 cosine x minus 1 must equal 0. Then from here, solve for cosine of x equals 1/2. And then we know that cosine of x equals 1/2 at pi over 3 and 5 pi over 3. So to state our final answer, including all values, we have x equals pi over 3 plus 2 pi k, and then x equals 5 pi over 3 plus 2 pi k. K is an element of Z. Alright, so all of these are mostly using our factoring and then getting it down to where we can use the zero product property. So remember, you cannot divide by a trig function, you can multiply, you can add, you can subtract, but you cannot divide. You want to get it down to a point where you have cosine of x equals some value you're familiar with in your unit circle. When you're solving for all values, you need to include everything using the 2 pi k. When you solve for just some of the values, like here, you can leave it just like this. Alright, and so that's all we're going to do for today, and that is it.